40 seconds.
About 40 seconds. Okay, I got about 40 seconds. I think we have everything up here. Cool.
Know when
Going back in time.
Touch
I like
trash.
this.
Oh yeah, this will be fun.
It'll be fun. All right, so we're gonna go. You tell us at 10 seconds. We'll start Instagram at that point.
Same, you can go live. 10-second mark.
Welcome everyone, Michael Ferrara from D-Sport Magazine, and joining me today, I've got Dirk Starkson from ACT, Advanced Clutch Technology. Dirk, nice to have you here today.
I'm glad to be here. This will be fun.
It should be fun, and we're going to make sure you guys are paying attention by giving away some more Harman Kardon gear. We've got this right here. This is the Esquire Mini, I believe it's called. Do we have a box for one? Grab one of those. Esquire Mini 2. So here's the cool thing about this.
This is the box.
This is the box. This is the product here.
What
is this? Well, you hook it up to your Bluetooth. It's a Bluetooth speaker and microphone, so it's great for doing conference calling. But better than that, you can always have it with you because it's also a battery. You carry this around, you need to charge your iPhone, do whatever, bang, you plug it right in the USB port, and you're good to go there. And we're also giving away a Citation 1, one of these units right here, which will connect to Wi-Fi. You can use Google Home, Google Assistant, all that kind of good stuff through it, and also sounds really good. I got one of these at my house. We have one at the front desk here, and some pretty cool stuff. So we'll have some quizzes throughout the show here, and we'll probably be giving away 2 of each, maybe 2 and 4. We'll give 2 away, 2 of the Citation 1s and 4 of the Esquire Mini 2s we're going to be giving away. And Dirk and I have known each other for a little bit of time, right?
A little bit. A little longer than I want to admit to, I think, at this point.
Well, yeah, so I mean, when I got started back in the days, there wasn't very many options available for a performance disc, a performance clutch upgrade on an import vehicle, on the Japanese vehicles. And in my trials and tribulations of trying to find something that worked, that's when I came across Dirk. And how did you kind of get into it?
Wow. Well, 41 years ago, I can't believe that, but I worked for a company, Kennedy Engineered Products. They built engine adapters and clutches for Volkswagens.
Okay.
So I was in the VW scene in the late 70s and 80s. And so they adapt different engines to the VW transmission. And so, you know, this is back when their sand rails are hot and import the VW Bug drag racing was just in full.
And they had all those kits. I mean, you could make a VW Bug into just about anything back there.
Oh yeah, you want to make it look like a Lamborghini? Yeah, well, sorta. Anyway, but you know, nobody wants a Volkswagen engine in the back, so we were adapting all kinds of different engines to that over at Kennedy. But with the VW, the clutch fits within the bell housing. So whatever power plant we're putting on it, we had to have a really strong VW clutch, and that's where Kennedy came in, and that's where I kind of learned the trade from. And so I've been involved with performance import clutches, or clutches in general, for 41 years now.
So the VW, that give you a restriction of actually how big of a clutch you could use? Because I guess the OEs would typically, if they had more torque handling, they just put a bigger diameter clutch in, right?
Yeah. I mean, really, the size of the clutch is more dictated in general by the weight of the car. Really.
Okay.
Because you can apply more clamp load. Like, let's take a Honda Civic. Honda Civic, you know, big D series, you know. It has a 212 millimeter clutch.
Okay.
But the clamp load's about 1,000 pounds.
Okay.
On a S2000 has a 212 millimeter clutch, but it's not a very heavy car, and it's got I think it's, if I remember right, 1,700 pounds. Of clamp load.
So 70% more. Yeah. Okay.
Yeah. So that's how they make up for the extra power from the S2000.
Gotcha. And I'm looking here, and I'm having flashbacks of the early days of import drag racing here. And tell us what you've brought for us today.
Well, before I get into that, let's go over a little bit of basics.
Okay, clutch basics then. Here we go.
Real basic. First of all, I'll say if you have a stock car or near stock car and you're driving on the street, you probably want to run a stock clutch. You don't need a performance clutch, and you probably don't want a performance clutch, in all honesty. So I'm not trying to shoo away.
Well, sales, I mean, I think there's one exception to that.
Well, there are a few exceptions.
I mean, The problem with some of the OEM clutches is the cost too. You know,
that's true.
It's going to be more expensive than some of the aftermarket options, but I think you're going to get into explanation here to kind of.
Yeah, there are a lot of trade-offs on some of the designs that are out there. While we try to limit some of the trade-offs, there are going to be trade-offs. Let's say you have a clutch that'll handle 40% more power. Well, typically that's going to come at the expense of a stiffer pedal from having more clamp load, or a more aggressive friction material. And then now you get a real aggressive, harsh engagement.
Yeah,
you
the
don't want that on the
drivability.
street, you know. But there definitely are exceptions. If you are racing the car, even if it is a stock car, and you want to meet safety regulations, and there might be SFI regulations on that you have to meet, or you just want it safer. Like we have this clutch here for the SRT4. That's our twin disc race setup. Well, the stock SRT4, that's this one here. We also have a street version. So this is more the hardcore. But the
Are you talking about the Dodge Neon? The SRT4?
SRT4 guys don't call it
I know.
neon.
That's
Yeah,
why.
that's
I'll see
taboo.
if you knew that. I'll see if you knew that.
You don't call it a neon, yeah. Although the people that aren't in there, they always do.
But on that same note, is it a Miata or is it an MX-5?
Yeah, true.
Okay. Anyways, back to clutch basics.
So anyway,
here. Sorry.
the stock clutch on that uses gray iron, and really it's an unsafe setup. If you're turning up the boost at all, or you're driving it hard, and you're overheating that clutch, when it fails, it does it in spectacular fashion. You can go on YouTube and see some of the videos. It blows up and goes into the radiator, breaks off the intake,
now this is
ventilates the bell housing.
This is actually the Flywheel's doing this, or the actual this ring here?
Yes.
Okay.
Both.
Wait, both. Oh,
Yeah.
both are made out
Yeah,
of.
they're.
It's not even ductile iron. It's just gray iron.
It's gray iron, and it's just the wrong material. Really, they should have, in my opinion, they should have chosen ductile iron. But I mean, we get into material selection later. But anyway, yeah. In that case, yeah, the stock clutch. If you don't want to run it. But
so there are some exceptions, but
sure.
If you have stock power, if you're going to drive the car like a commuter, or just take it really easy, stock clutch or something very similar to that is probably the best choice for you.
Yeah, you'll have typically an easy pedal, smooth engagement. It's quiet. It's going to last a long time. And that's not always the case with the performance clutches. So.
There are some trade-offs to get some of the benefits you can get.
And so today,
All right, so now we can get to these B-Series clutches.
Yeah, this is going back to some of my heritage here. Okay, so we got some B-Series parts here.
I'm recognizing these.
And I wanted to point out some of the failures that can happen. And point out some of the design features that we've implemented on our B-Series clutch way back in the day, probably about 2000, I think is when we finally came up with our own cover design and stuff. But let's look at some common failures. Here's a Integra disc where the lining blew off.
That's probably mine.
And no, yours would look more spectacular.
Okay.
Yeah, but. Anyway,
Wow.
The lining blew off because of excessive RPM. These linings, they don't have anything to really hold them together except for the resin and the friction, the fibers. So with high RPM, they'll blow off. And typically, it's not engine RPM that is the problem. It's input shaft RPM. So that's something to remember if you're road racing and you're coming into the next corner and you're fourth gear wide open and you're going to get ready for it, shift in a second. Clutch is down, so engine's not seeing that RPM. But the clutch disc, since you went in a second, it just spun the disc up to whatever RPM.
It would be if you let the clutch out, yeah, which could be 12,000 RPM, and then all of a sudden, poof, yeah.
And all of a sudden, yeah, the clutch doesn't want to disengage because all the friction material is stuffed into the pressure plate. And so what we did on, where are they? Here we go. On most of our linings, we have a steel backing. Here's a one that isn't steel back compared to one that is steel back. Now, here the trade-off is that the steel back is going to be a little bit heavier, which adds inertia to the clutch disc and potentially maybe slower shifting. Although
probably not too much there.
Not too much. I mean, you're not adding a lot of weight. I mean, you can kind of feel the difference here.
Yeah.
It's pretty negligible in this case. But anyway, just so you get the idea of what you can do to alleviate that problem. On the pressure plate side, this is an old I'll call it red clutch.
Red clutch. I remember these clutches.
Yeah. It's double diaphragm.
Yeah.
So here, and I'll turn it over. You can see there's 2 diaphragm springs. That was an old method that some people would use. We never went into making double diaphragm clutches because we have the engineering with the diaphragm springs to make a single diaphragm and get whatever clamp load or spring load we need. Really.
So let's talk about why this was being done. So why this was being done was the single diaphragm by itself wasn't enough clamp load.
Yep.
The things you could do to get, to re-leverage it to get some, which we'll talk about probably here, maybe didn't give you enough. So your next option was, well, let's take 2 of these things and stick them together. But the problem was it usually puts you way too much pressure instead of getting you kind of where you needed to be.
Well, you're not only increasing the spring load and clamp load, you're also increasing the friction because you have the surface of one diaphragm rubbing against the other one when you go to push on the pedal.
Yep.
So if you were to graph a double diaphragm, because what we do, we'll clamp load our clutches and we'll graph compression and rebound. Well, you'll see this big gap between compression and rebound, and all that is friction. So
yeah.
that's how it is.
So you guys basically got away from doing that and figured out a way to make your own diaphragms that were the rate that you wanted, the desired rate.
Right. At Kennedy, Hobart Kennedy, the owner, he taught me some of the basics with designing diaphragm springs, and then we got really creative, designing other diaphragms for all kinds of different applications. And we started ACT, and we just kind of we went all over the place with diaphragm springs.
Probably most everyone watching this in the generation that's been around for even 41 years, the clutches that of doing this, the clutches that we're most used to are these diaphragm clutches. But before that, there was the Borg and Beck style, the long style, these clutches that actually had coil springs in there, which gave you something different than that. This was kind of a new invention that OEs came out with probably in the early 70s.
Yeah, and originally they got a really bad rap because these are big diaphragm springs that are real flat, and they had a lot of over center effect. So the guys go out to the drag strip, and centrifugal force would hold them over center. So they're at the starting line, they rev the motor, and the clutch doesn't engage till the RPM comes down. So that they got a real bad rap initially, and they just weren't engineered for a drag car at that point. Right. But you can tailor them to all kinds of stuff. I think I want to back up a little bit and go over. Let's see. Well, first of all, the need for a performance clutch.
Okay.
There are several needs. Obviously, first one is going to be torque capacity. You want a clutch that's going to hold power. But clutches are rated by torque, not by horsepower. And that's important to understand, especially if you're shopping for a clutch and they say, our clutch will hold 1,000 horsepower. Okay, what RPM? Because
if that's at 10,500 RPM, that's only 500 foot-pounds of torque.
Right. You compare a diesel truck that's making 300 horsepower versus a turbo 4-cylinder making 300 horsepower. Torque is way different. Obviously, you don't want to put that little turbo 4-cylinder clutch onto your diesel truck.
Exactly.
It's making twice the torque or something.
So torque capacity, that's one of the reasons why you're going to upgrade your clutch. And it's kind of one of the things, I think, often as a consumer out there, the enthusiast, they're like, oh, well, I'm just going to get this clutch because it handles 800 horsepower. Yeah, I'm only going to make 400, but I want the 800 horsepower clutch. Don't do that. You want basically, the number one rule of choosing the right clutch is get just enough torque capacity. Maybe a little bit of headroom there because as they wear, they're going to change a little bit, and that curve of how much torque capacity it has, it's going to grow a little bit. It can handle a little bit more, and then it's going to come down and handle a little bit less over time.
Yeah,
so
I'll probably scribble something on the board.
Perfect.
Show that, but yeah, exactly. Our clutches are rated at whatever the torque is calculated at the flywheel. So if you have if you look at our catalog, our website, we don't have a catalog anymore. Nobody has catalogs anymore, right?
I miss catalogs.
So anyway,
I love catalogs. It's the easiest way to look something up.
Yeah, I'm a hands-on guy. That's why I do this. I want to touch things, and say, hey, look. But if you go on our website, all of our clutches are rated by how much torque they'll handle, and we got some simple math to calculate that. So that's the first thing you're looking for is torque capacity. But also you need to know what the heat capacity is too. How much heat does that clutch have to absorb? And a lot of that depends on what you're using it for. On my Jeep Wrangler, we went with a much bigger clutch, wider surface, because it's a heavy vehicle. I'm going to slip it a lot on the trail and whatnot.
Gotcha.
So in that case, I want to have a lot of heat capacity. And if you're drag racing and launching the car, let's say all-wheel drive, like the Evo, like this has a lot of surface, a lot of material to absorb the heat.
A lot of mass just to kind of draw that heat out.
Yeah,
place for it to
certainly,
go.
yeah, we can make small clutches like the one for the SRT4 there, but you're not going to want that on your all-wheel drive drag car. There's just not enough heat capacity.
All-wheel drive is the equivalent of putting slicks on a rear-wheel drive car. It has so much load there, and people don't think about it. It's a two-part system. It's not just how much torque you're making at the flywheel side. It's how much traction you have at the other side, and that's really going to determine what's happening to the clutch, how much abuse it's receiving there. And we've got a question coming in.
Right here. What happens when the clutch pedal doesn't come all the way up on launch?
There you go.
I have to know the application really. Within the clutches themselves, there's not much that's going to change. But in the operating system, typically that's where you'll see problems.
So with the hydraulics and the throwout bearing and stuff like that.
Yep.
Gotcha.
Not always, but I'd have to know the exact scenario to really be able to. It's hard to diagnose sitting here.
But it's so most likely look at the hydraulic system, see if there's anything going on there that is not letting it work. When the hydraulics are working right, tell them how the clutch should feel if the hydraulics are working right and you've got the clutch set up right. What kind of feel should they get initially from the pedal to where it releases, and as they release off the floor and the clutch comes back in and engages the power, how should it feel?
Well, I mean, it should feel smooth and predictable. It should be the same whether it's high RPM, low RPM. And it should be somewhere in the mid-stroke. You don't want it to engage down by the floor because you won't get adequate disengagement, especially at higher RPM, because everything's moving so fast and you got windage and everything else in there. So you want to have enough air gaps so you're not gonna mess up your transmission. So somewhere about mid-stroke. For it to change though, that's unusual. We did have one scenario one time, a guy with a Mazda where he took out the balance shaft and this thing is way overstroked. I mean, this motor is this Godzilla motor, and we're finding at high RPM, the clutch arm was vibrating violently.
Well, the clutch fork itself was actually vibrating. Wow.
And the diaphragm fingers, all that, they weren't, but the clutch fork was just. I mean, the whole car's shaking anyway, but it was what was happening is it was pushing the fluid back into the reservoir of the hydraulics, and now you go to stab it and it's down by the floor. So we ended up putting a return spring on the arm just to keep it from shaking, and the problem went away. But that was a weird one.
Yeah.
That was a weird one.
A lot of things that happen in clutches. Oh wait, we got another question. Go ahead.
I love my ACT clutch and always recommend it to my friends. Will you guys
Thanks.
produce a twin disc for the R1541JZ?
No, but our mod twin should fit in there really well. If we get enough demand for it, I'd like to do that because a lot of guys are taking that transmission and they're
It's a swap, like you put it with a 2JZ or something?
with the 2JZ.
Gotcha.
And the 1JZ clutch on the 2J is not a good scenario. It's there's too many weaknesses in it. We've done everything we can on the 1JZ clutch to beef it up. We put stronger straps and beefier rivets to hold them because the straps are really narrow. So we went with wider straps and things like that. So So yeah, I think a twin would be great for that. I don't know if there's enough demand for it. A lot of people are steering away from that transmission. They're not as plentiful.
It is a challenge out there. Another question.
Right here.
Yes.
Pro Bearing. Do you guys no longer offer a twin disc for a B series?
Yeah, we offer a twin disc for the B series. It's a full race setup like that over there.
So it'd be on the 7 1/4 inch platform.
Yeah, it's 7 1/4 inch. Yep.
7 1/4 inch platform. Okay, so we're gonna get back to the program here.
Okay.
We were talking about torque capacity. You know, one of the things you're going to look at when
Torque
doing
capacity, heat capacity,
and heat capacity. We talked about heat capacity.
burst strength, so this doesn't happen.
Burst strength. We got
Yep.
that handled.
Yep.
Let's see. What else do we need?
Safety's a big one.
Safety's a big one. SFI. Oh, let's talk about the other way a clutch designer can change the clamping force through moving that fulcrum, moving that pivot point.
Well, let's.
And
let
the
me
pros.
let me go back to the math.
Okay, go. He's going to go to the
back
math.
Okay, I'm going to go over the board here because everything's based off of this simple formula. And it's it's just it's your basic multiplication, right? Torque capacity, pounds of clamp load, coefficient of friction, the number of surfaces, and the radius of gyration. So the size of the clutch. So size of the clutch, how many surfaces? In this case, 2. Usually, let's take an organic. Okay, organic. Let's see. You're going to have 2 surfaces. You're going to have a radius of gyration of 0.307. That's going to be like a 225 millimeter. Coefficient of friction of 0.25 is like organic. 0.32 is our that's what we rate our ceramic for. Man, I just cannot write.
I'm worse. You can read yours. That's good.
Okay. So and clamp load, in this case, let's go 2,200 pounds. So you got pounds and inch. This is in feet, right? So you got pounds and feet. So that we get
so you get the same units.
And I forget where we're at. I'd have to look at I can't do the math in my head, but.
Well, you're about 1,100 times, right? That would be, if we go 0.25 times 2, 1,100 times 0.307. So you're probably about 350 foot-pounds of torque. Sound about right? Will you buy that?
Actually, yeah.
That's
right.
that?
That's right.
I'm around. You don't need a calculator.
The reason why
here.
I know that is because our twin disc, this is where I got the numbers from. So if you double the surfaces, now you're at about 700 foot-pounds of torque.
So single. Perfect.
So single would have 2 surfaces, and it'd be 350. Now, so you got the clamp load. So in most cases, you're not changing the number of surfaces. You're not changing the size of the clutch. So now you're talking clamp load and friction. So that's I wanted to get that out there so we can discuss it.
And the way that we can change clamp load, we can go way over what we want by putting 2 diaphragms in there, which we don't really recommend.
You can do that.
Well, you know what though? Before we get in that clamp load, as you go higher in clamp load, and you just if the only thing you did was put in a stiffer spring, that's a problem, right? Because I remember that was one of the things early on that we figured out with these clutches. Okay, now we've got a stiffer spring in there, but now the whole clutch cover is moving around and deflecting.
That's true. That's true. That becomes a real problem. That's why our cover stamping it's different. It's got this different shape than what the original equipment has to make it more rigid.
It looks like is it a thicker material also?
Just slightly. The
slightly?
problem we're running into on the B series, I mean, really, it is tight for space. This is based off the factory. Let's see who made FCC made that original clutch cover, and you can see these tiny little rivets. They were holding the drive straps. Here's the one version. This is I'll say they say it's a performance version. It has increased clamp load, but they're still using these little tiny straps that drive the casting, and these little tiny rivets. And what was happening is the straps would tear off, and the rivets would shear off.
Nice.
Also, at high RPM, these little retainers, they would actually go like this. And now,
really?
And we'd see them bend out like this. This clutch had that until we took it all apart.
Okay, now what is that retaining? What is that actually holding?
That's holding the diaphragm down to the casting.
Okay.
So when you push this and the diaphragm raises, it makes sure the casting follows it.
Gotcha.
But at high RPM on this application, they were actually bending. So what we did on our clutch, this is going back a long time ago. First, we were modifying these by putting stronger straps and using stainless steel rivets.
And weren't you even welding a ring in there at one point?
Not on this application.
Not on this application, but on some of the applications
Yeah,
you had
some
even
of them we were, yeah. But what was happening is the straps would tear off, and then the casting's bouncing around in there, so that's no good. So on ours, since I think about 2000, we made our own. We made our own cover stamping. We have stronger straps, and you can see the straps, they're bent in an S shape, and that provides lift. So it's keeping the casting pushing against the diaphragm without having the retainers, and it's not RPM sensitive.
So it's not just a strap in that sense; it's also a spring.
Right.
Gotcha.
Right.
Gotcha.
So if it's
nice.
producing, I think our heavy duty is like 1,700 pounds or something like that. Yeah, we're gonna lose a little bit. It's probably 1,800 pounds through the spring. We're taking 100 pounds away through the drive straps. But we're using a much bigger rivet and a wider strap. And then when we did that, we found out that the cover stamping that we spent a whole thousands of dollars on tooling to make that. The stamping's hitting something in the case. And we got all 3 different B series transmission cases and starters, and we couldn't duplicate it, but it was really close. So now, ever since then, you can see a little bit of machining here. We've machined the cover down, but we had to make room for the wider strap. And so every one of our B series covers gets turned on the lathe just to make a little bit more clearance. But yeah, it's really tight for space in there.
So these right here, I know what this is used for. So let's talk a little bit about that.
Okay. So in order to get clamp load, you can either put a stronger spring, or you can change the ratio of the spring load to the actual clamp.
You want me to demonstrate that? Is that the fat kid on the seesaw?
Let's see if you can do it.
Is this the fat kid on the seesaw? So you got the fat kid on the seesaw.
That's me then.
All right, and here's the seesaw, and then the skinny kid. Let me see if I remember right. Oh yeah.
Yeah.
So he has to be there, and the skinny kid would have to be at the end of it, right?
Right.
There we go. Look at that. That's art.
Okay. So by moving the fulcrum points closer together, you can get more clamp load.
But there's a trade-off.
But there's a trade-off. Now when you go to push the clutch, you know, like it would be it would, so you can lift a heavier person.
Right.
Basically, in this
one
area.
you could, yeah.
Okay. But you're not going to move them as far.
Ah.
So the closer you get that way, well, you can't move them. You can't. So in the case of the clutch, sorry, I'm getting confused. Not confused. Okay, which do I want to relate it to? The clutch or the guy on
the fat kid?
Or me on the seesaw? Anyway, but in terms of the clutch, by ratioing it, you get less lift.
Less lift.
And so it takes more travel to operate, and it makes for a muddy feel.
Yeah,
It's not very crisp, you know, like boom, it doesn't engage that quick. It feels really odd if you go too far.
Yeah. No, I've driven a few clutches that were done too far, and
the other thing is it also gives you less working range. So if you were to graph the clamp load, typical diaphragm spring kind of looks like this when you plot it. And this is load going this way, and this is distance. When you install it, it's in this position. You've compressed the spring to where it's over center, and that would be installed position. As it wears, it goes this way. And then at some point, now you've lost enough clamp load where it's not going to hold the power, and you're replacing it. Usually, we allow for 80 or 100 thousandths, 2.5 millimeters of clutch disc wear for or more. Usually it's more than that, but at least that, so that at that point basically you're down to the rivets, so it doesn't matter. You don't need the clamp load because you're gonna be in there anyway. But in the case of like if you're gonna ratio a clutch a lot, if you want to get say a 50% increase or something really dramatic, well, all you're doing is you're taking this curve and you're compressing it. So now it's like this, you know, and so installed here and you can't get to that worn out position. It's going to wear out a lot sooner. You don't have you're sacrificing clutch life. That's
right.
Basically.
Because you're only getting this much clutch life instead of that much clutch life.
Right.
Basically out of it. Gotcha.
So if you have a stronger spring, you don't have to give up clutch life
Gotcha.
to get the performance.
But this was a technique used by a lot of companies initially in this, kind of before people figured out, we can, we could make a stiffer spring or a stiffer spring is the option.
Yeah, I think
they were doing a lot of this, right?
That's really where we excel, and I think we're a lot different than the other clutch companies. We manufacture diaphragm springs. And the other guys, typically, they don't. Either they'll stack them, or they buy them from something, or they'll swap it out of some other clutch, but they don't have a lot of options. And by not being able to do diaphragm springs, man, that really limits you. By being able to make our own diaphragm springs and conform them to the characteristics we want, we have a lot more knobs we can turn when we're designing a clutch.
Gotcha, gotcha.
Going back to this, I think you were going to point at this stuff. This is an old competitor's clutch.
I remember that.
Or face from one. It didn't actually come from this double diaphragm, but it's a B series. And what they did is they just machined it flat and dropped some bearings in there. And the bearings are moved in order to change the ratio of the clutch. That's all they're there for. And then you can see a little bit of glue in there. So they glue them in there. I don't like that for a couple reasons. The main reason I don't like is you're making point contact on the spring, so you're concentrating load on I don't know how many bearings those are, but I don't care for that too much. I mean, if you're gonna change the ratio, just make it casting, and that's what we did. Of course, we tooled up to make the whole clutch anyway, but in this case we have this wide area that we can. This side's not machined yet. And we have this wide area. We can move that fulcrum wherever we want in order to change the ratio. So what we've done on the B series is we increase the spring load by a generous amount, and then we'll also change the ratio a little bit in order to get a little bit more. So here's one that's been machined. So this is before and after the machining. And this one's been, it has a pretty aggressive ratio. It's probably from one of our max extremes where we moved the pivot in pretty far. And so that's what it looks like when it's finished. But I've seen them this one here has balls in it. I've seen other ones where they braze it and then remachine it. If you do have a double diaphragm, you're able to move it because you got to make room for that second diaphragm. So you just machine it thinner.
Gotcha.
But yeah, kind of it's kind of crude, in my opinion.
And what's this throwout bearing you have here? Why we?
This is off my daughter's car, which I drove here today. Actually. Subaru Forester. So this is another failure that I want to point out because
Subarus never fail. I don't.
You don't drive a Subaru, do you?
No.
Okay.
No, I never owned one.
Sorry.
Go ahead.
Sorry. I don't mean to pick on this Subaru, guys. I do. There are some things I really love about Subarus, but this is not one of them. So this is after 60,000 miles. She has a Forester, and the bearing froze and melted the plastic insert that's in it. Boy, the smell! We thought it smells like an electrical fire. It's like, oh no, and smoke's come out. Yeah, my son was driving it. So anyway, if you're getting noise when you have either your foot at the just touching it, then typically what you want to look at is the release bearing. If you're getting a noise at the very top. So I want to go over a little bit of diagnostics stuff.
Oh yeah, let's do that because
so
knowing what's wrong will help you determine what's going to be right.
So in this case, the noise it might go away when you first touch it, or it might get worse when you touch it. In this case, at the very end, when it stopped turning, it didn't make a lot of noise. Just it's like. Just this scrubbing in the pedal felt goofy because it's no longer flat. But with a throwout bearing, though, it'll typically change sound at the very top. With a pilot bearing, it's quite the opposite. Now this is the pilot bearing on the same car. It's dry. It's luckily it didn't freeze. With a pilot bearing, the symptoms are going to be that. Let's go back to the throwout bearing. Throwout bearing, it may change feel.
Okay.
The feel may change as the bearing's failing. In this case, like I mentioned, it just felt wrong. Also, if the bearing is over time, the lubrication goes away on the guide tube and on the clutch arm. Typically, the clutch will get stiffer. It'll be heavy, and one thing you got to look for is is it a lot heavier going down than coming up. If it is, then there's friction within the mechanism.
Okay.
And whether it's the arm or it's throwout bearing sliding on the guide tube or something like that.
So basically, over the life of the clutch, it shouldn't feel any different. If everything's working right, it shouldn't really, the pedal shouldn't feel any different.
At the end of life for the clutch, you can tell because on our graph there, you're kind of on the other end of the graph. So when you push down on the pedal, it gets stiffer. Brand new, when you step on the pedal, it gets lighter typically, or about the same.
Gotcha.
So back to the pilot bearing. Sorry, I'm jumping all over the place here. That's what I do, you know. You should try working with me. With a pilot bearing, it's going to make noise when you're at the bottom, when the clutch is disengaged.
Okay.
Because that's when the bearing's spinning. When the clutch is all the way engaged, then the whole crank, everything's moving together. This isn't working at all. So it's only when the clutch is disengaged that the pilot bearing is going to make noise.
Gotcha.
But then you can also have other noises at that same time. You know, with a pilot bearing, if a pilot bearing fails, a lot of times you'll get drag. So the clutch will disengage. You can feel it disengage, but it doesn't feel like 100%. And you go all the way to the floor, and it still doesn't feel like 100%. That's because of the drag of the bearing trying to pull the input shaft.
Gotcha.
So back to the B series. Remember the Group A guys?
Yeah.
Yeah. One time they're upset because the clutch wasn't disengaging. Well, it turns out their aftermarket crankshaft wasn't drilled deep enough for the input shaft. And so it was turning the input shaft. So it had nothing to do with the clutch or the pilot bearing or any of that. It was just a mismatch of parts.
Gotcha.
So.
All right, question.
What negatives are there from going from a dual mass flywheel to traditional type?
That's a good question.
I'd like to know the answer to this. I don't think I know the answer.
Dual mass flywheels are really unique. And let's see if I can do it justice.
Do we have one here, Gianni? And do we have any factory 2JZ flywheels by any chance? That's a dual mass, right?
I know it's easier when you have one to show.
We'll see if we have one here so you can kind of see it, but go ahead, sorry.
Okay, so with a dual mass flywheel, the whole purpose for having a dual mass flywheel, the whole purpose, most of the purpose for having springs in the disc is to quiet down the transmission. And so what's unique about a dual mass flywheel is that now you've added a lot more mass to the input shaft, and the damping for to silence the transmission, you've added a lot more mass to it. So I'm trying to think of how to explain. So let's take a regular disc. You've got the big heavy flywheel at the end of the crankshaft. You got your pressure plate mounted to it. And the input shaft into the transmission has it's after these dampers here.
Okay.
So it's going to keep the transmission gears from making a lot of noise because of the springs. It gives you a little bit of cushioning there, right?
Gotcha.
But the problem is, especially on the newer cars, they're making transmissions lighter. They're putting lighter oils in. Remember last time we talked about exciting. The gears get excited. We'll say as the engine return, they're easy to shake because there's not a lot of mass there. I mean, it's easy to shake this. Try doing that with a flywheel, right? You can't. It won't move that fast. And so here you've only got an input shaft, a little bit of the clutch disc, and it goes into the transmission. On a dual mass flywheel arrangement, now the damper is halfway into the flywheel. So you've got half of the flywheel, and then you got the damper. Now what's connected to the transmission that would have to excite the gears is the second mass of the flywheel, the pressure plate, the whole clutch disc, and the input shaft.
Oh wow!
So yeah, you've added all this. So it doesn't take a lot to tune out the vibrations when you have all that mass.
Right.
Yeah, you'll see a lot of cars these days where you you crawl under the car, you have it on the lift, and you say, what the heck is this big old hunk of metal for? Or this hunk of rubber? You know, they start adding weight just to quiet things down. Well, that's essentially what they've done here is they add all this weight to the input shaft by putting the damper ahead of the clutch.
Got you. So does it get much louder switching from a dual mass flywheel to a standard?
It really depends. Depends on the application.
Okay.
And in some cases, you don't notice it at all. Other cases, transmission can be like a box of rocks.
Oh, really? Really?
E46, BMW, oh man, those transmissions, they like to make noise. Yeah, I don't know how much of that is in the engine tuning and that arrangement, how much of it is in the transmission, but yeah, they tend to make a lot of racket.
All right.
So
I hope that answers your question there.
Yep.
All right, so where did we end off here? I think we pretty much talked about how the clutch is designed.
Let's talk about this.
Okay.
Okay.
What do we got here?
All right. So this is actually out of a 996 Porsche, and the reason why I brought this is just to demonstrate just this narrow friction band that it has, and this really light, thin casting. I mean, there's not much to this thing.
Oh yeah.
And yet it's on a
It's probably lighter than the B Series one, to be honest.
On a car
with
that makes good power.
Right.
And these are troublesome. You know, it's got these little tiny rivets. I don't know why they wanted this design, but anyway, we can fix that. We have fixed that on some applications, but the heat capacity. There's two things when you talk about heat capacity. You have heat stress.
Okay.
And heat soak, I'll call it,
okay.
or let's say heat sink, basically. So heat stress would be that flash of heat when you slip the clutch, taking off from a street light or something, and you don't time it just right, and zing, that heat is that's the surface heat. That's like if you don't have a lot of surface area, then you're going to overheat the material, especially if it's an organic material. It's a little more sensitive to heat.
And that's when you're going to get a lot of color from the heat.
Not necessarily.
Oh, really? Okay.
But you'll get a smell.
Okay.
If it's just that little bit, that flash, that heat stress that you're putting on it, you'll burn a layer off the friction material, so you're sacrificing a little bit of clutch life. And since you don't have much surface area in this application, you only do that so long before you're replacing clutches, and I think they do that often on these for some reason. Now let's talk about heat soak. That's more like when you're slipping it over time, and the general amount of heat it's got to soak up. We talked about that with the.
Well, it's a heat capacity, like torque capacity. It's a heat capacity. How much
the heat sink?
Yeah, how many calories can you put it in there before you're going to have some issues?
Right. If you're road racing, and you're shifting over and over and over and over again. Well, heat stress might not be too bad, but the heat soak, or the heat sinkability of that thing.
Gotcha.
Sinkability. Anyway.
Very cool.
So yeah. So anyway, that's why I brought that along.
All right. So that pretty much covers the basics of the clutch itself, but that's the basics when you have a single disc clutch. When you go to a multi-disc, what changes?
Well,
I mean, in the equation, if everything else stays the same, we got twice the torque capacity.
Yeah, twice the torque capacity as long as everything's the same. In this case, like on this clutch, this is for the C7 Corvette. It's 10.5 inch, so it's a big clutch, and it's got it's a twin disc. We have a forged cover, so it's very rigid. That way we can get, since we got so much efficiency in the cover, we're able to keep the pedal load down and still have the clamp load and the working range that we want and the clutch life. But to answer your question though, yeah, this will handle a lot of torque just by adding a second service. We haven't changed it a lot. It's actually a little bit smaller than the factory clutch, but
smaller in diameter.
Yeah.
Okay.
The stock one's like 12 inch or something. This is 10.5.
Oh, okay.
But on smaller twin disc clutches, like the one for the SRT4, they'll shift fast. They're because a lot less inertia, so they'll rev really fast. Really good for road racing. Decent in drag racing, just because of the materials we're using for the friction material. But there's no cushion. There's no dampening in in the
Not for your daily
drive system.
driver.
Not for your daily driver.
Right.
What typically happens is you're going to get a lot of gear noise, and you're going to get spline wear. I've had people, hey, why don't you make the splines, why don't you heat treat them, make them harder? Well, okay, if you want to change input shafts, yeah, because the input shaft's really hard. So we intentionally make the splines not as hard. I mean, they're hardened, but not to the point where you're going to wear out input shafts as much. So that's the goal there. But really, an engine is like a rotary hammer. You know, when an engine does not turn just like this. No, it's just banging, it's pounding, and that's why it's hard to keep flywheels on. That's why drive straps fail on pressure plates. That's what wears out splines on the clutch disc, especially on a turbo 4-cylinder. Some of the V8 cars, like the C7 deal here, the splines will probably never wear out. They are just not as violent as like a turbo 4-cylinder.
Interesting. So clutch diameter, a lot of that in choosing the right one has to do with that heat capacity of it, right? The thermal sink that it has, and you know, a 7 1/4 inch isn't really good for the street in most cases because you don't have enough mass to get everything out of there, to get the heat out of there. Right. There are some advantages to having smaller diameter, and there's trade-offs with everything, right?
Exactly.
So with the Mod Twin versus the 7 1/4, what type of applications is this kind of geared towards, and which type would that be geared towards?
Well,
I mean, there is some crossover, of course, right?
Yeah, there's crossover. We chose not to make a 7 1/4 for the Evos because with the all-wheel drive, man, you get a lot of traction. You can generate a lot of heat, and most of these guys, they're still running them on the street, or they're taking them to the drag strip, and in both cases, you've got a lot of heat to contend with. But also, we wanted a clutch that's going to last. The 7 1/4 just don't last that long, and because of the spline wear. So we just opted never to make one for the Evo. We said, no, if we're going to make a clutch for the Evo, I want to step up to a bigger size and have less trade-offs, and that's what we've achieved with the Mod Twin.
Very good.
So the Mod Twin is 225 millimeter, and now it's really hard to get something in between, because you need a very strong spring center to handle the load and the torque and the torsional vibrations that you get from that motor, because they're pretty severe. So
you couldn't go to a 210 millimeter or something like that. You just can't get enough.
I mean, it was really hard to squeeze in the hub between where the friction material is and have some kind of drive system that's going to be robust enough to handle 1,000 foot-pounds of torque. So that's what we have achieved here. So
now we've already done a video specifically on this clutch, the 225. What is it? The Mod Twin, right?
Twin.
Mod Twin. The 225 Mod Twin. We've already kind of.
This is the special D Sport.
This is the special D Sport edition that will be.
Our laser. The guys in the shop said, "Hey, can we put their logo in there?" Sure. So they lasered the logo in.
So that'll be going in Sam's Evo, and if you have questions about this is for more than just the Evo. You have some more applications for that, right?
Right now we have the Evo and the Subaru STI. It should also fit the Bug Eye, but I haven't tested on it, and I don't know if you'd want to. I don't think the transmission would support it really. Yeah. So I don't know if I'd recommend it. It's a lot of investment for a transmission that probably shouldn't handle. But they start off with 700 foot-pounds of torque with our basic street setup. That would be with these discs, and I've driven on them. It feels like a stock clutch. Actually, it feels better than the stock clutch. The over center effect's a little better. Just the pedal feels better than the factory clutch does. It's really smooth. It's quiet. You'd never know it can handle 700 foot-pounds until you put the power to it.
So do we need to know anything else about clutch basics, or does that wrap it up for 101?
Well, let's see. I guess I'd like to talk a little bit about friction materials.
Oh yeah, that'd be good.
That is a big portion of it. We've talked about diaphragm springs, and we can do all kinds of things. I'll backtrack a little bit. Here's a couple examples. We put like this hump here for centrifugal assist, I'll call it, to kind of counteract the ribs that we put in. We put the ribs in there to make the diaphragm more efficient, so it doesn't take extra travel. That way we can get the good balance of pedal feel, clutch life, clamp load, and all that is determined by what we can get out of the diaphragm spring and really out of the cover. You've got to get efficiency somewhere to make up for the extra load you're putting on everything. But okay, so back to friction materials. See, I'm jumping all over.
Yeah, jumping all over the place. This is your organic stuff. That's
organic. We say has a coefficient of friction of about 0.25. So if you're doing the math, that's what we use. On our ceramic, we say it's 0.32, so it's about a 28% more torque, higher friction, higher torque capacity.
There we go.
That would be like with our ceramic. And obviously higher heat capacity as well. With an organic, they're held together with resins, and as the clutch gets overheated, the resins will kind of boil out and it almost becomes like a lubricant, and the friction material will disappear. So that's if it gets really hot. With a ceramic, that's not the case. The ceramic is going to maintain a coefficient of friction a lot better than the organic will when it gets hot. And I mean, really, you shouldn't get it that hot.
Right. And then within each of these categories, there's a range of quality and performance from the materials. There's organic materials that don't have as much, what is that, copper and stuff stuffed into there?
Right, yeah, the mix making up the organic materials, it's very critical. And we've tested a lot of different materials. We're pretty happy with this material. We had another material years ago that we can't get anymore, unfortunately. It was really good, but I think we pretty much matched the performance we were getting with that. And with this friction material, yeah, like you said, it has some metals in it. What the metals do is it helps pull the heat away from the surface so that it can recover from the heat of engagement. Primarily the heat goes into the mating parts, but some has to go into the lining. In the case of a ceramic or cerametallic, it's pulling more heat away, and it's also heavier. It's a much heavier material, so you don't want to have a full ring because then it's too heavy. You have too much weight. So we try to find a good balance that'll handle a lot of heat and have good wear rate, but and good coefficient obviously, but not too much weight. If you have too much weight, now it's harder on synchros and transmissions and everything else.
Cool. And the other material that's sometimes used on clutches would be sintered iron, right?
Yeah, centered iron is what we're using on our smaller twins, the 7 1/4. I think you can lift that off.
All right.
Or maybe not.
Oh, I can. I think I can do
Now
that.
with centered iron, it's not a very strong material. You just kind of have to.
Oh, okay. There we go.
It's not a very strong material, so it's bonded to the plate, and it's small enough where we can have almost a full surface, and you almost need a full surface just to pull the disc has to do its job pulling the heat away because it is small. In the bigger clutches, you can deposit more of the heat into the mating parts, but when the mating parts are not that big, the heat's got to go somewhere. We sell a lot of these twins and triples, a lot of triples for the drift guys.
Ah, okay.
Like Forsberg and some of the other guys. So primarily they're triple discs, but same size, same arrangement.
Yeah, and a lot of times going to the smaller ones, in order to get a decent life out of them, you have to go from a twin to a triple, right? Is that one of the advantages of going from a 2 to 3? Do you get longer service life out of it?
Yeah, we can usually get enough torque capacity out of the twin, except for the guys making really big power.
Right.
But it's the heat capacity that's the problem.
Gotcha.
So we add another disc, another floater, and now you're distributing that heat over a little bit more mass, a little more surface.
Very good. So do we have any questions out there? You guys have any questions? Because if not, we're going to have to give you one of our quiz questions for today. Dirk doesn't even know what it is. And I'm thinking it up right now. So we'll see if you guys are ready.
Don't
here.
ask about the fat guy on the...
Yeah. The fat guy on the seesaw.
on the seesaw.
All right. So let's see here. I think the first one, let's see here. We didn't. One thing we didn't cover was the solid versus sprung hub. I think. Do you want to just go over that quick while I think of this question?
Oh, still thinking. Huh?
Yeah, I'm still thinking.
Okay. Well, with the solid hub, and we offer a lot of our clutches with solid or spring center. But with a solid hub, you get rid of the dampers in the clutch disc, and so it's going to be lighter. It's easier on the synchros in terms of the load. Problem is now you don't have that cushioning, so it can take more. It's going to have more pounding, but the rotational mass has been reduced. So the springs help to soak up some of that. In this case, on the Mod Twin, I think they bottom out about 300 foot-pounds.
All right, I think we got a question.
Should a throwout bearing always touch the diaphragm?
In most of the hydraulic systems these days, yes, they do. On older systems, there's usually free play in there. For the hydraulic system, the hydraulic system self-adjusts. So what happens is you have fluid in the reservoir, and as soon as you touch the pedal, it closes off the port that feeds the fluid into the system. So it closes it off, and it'll pump to the slave cylinder and operate the clutch. And then when your foot comes off of it, then it equalizes. So the throwout bearing's right there on the fingers of the diaphragm in most cases. Sometimes they're preloaded. A lot of the newer cars that have the annular bearings, there's a lot of friction in the bearings, so they put a heavy spring to actually push the bearing up against the fingers, so they make sure it makes contact all the time.
All right, so I've got that question ready for you. Now, we talked about clutch basics today. One of the things we talked about was torque capacity. And we gave you guys a formula up on the board there, which is still behind me here. And we'll see if you guys were paying attention. Because what I want you to do is tell me the 4 things that will affect torque capacity. 4 ways you could change a clutch to increase or decrease the torque capacity. What could you do there? There's 4 things.
Yeah.
Let's see, how we doing out here? Anybody awake? And then the other question is, the people looking at these answers on our team, do you guys know the answer? That's the real question. You know, Tyler's looking at the answer there, and if somebody's saying it's peppermint schnapps and this and that, you know, we're getting anybody? Wow. Okay, I'll make it even easier. Just name 3 of them. 3 of the things you can do to a clutch design to change the torque capacity.
I didn't do my job right.
I guess nobody was paying attention. Nobody was paying attention.
Sorry.
You know what? If no one gets it, Dirk, you get to take home both of the units, okay?
I know it.
So.
All right. Yeah. Nobody answer, okay? I want the units, okay?
Really? Okay. All right. More hints? Really, guys? Are we even having guesses coming in right now?
Guesses?
They're kidding answers.
Kidding answers.
I caught the stream late.
Oh, really? They caught the stream late. Okay. Well, think about it. Take guesses. Take guesses. What you could do to increase the torque capacity of a clutch.
4 things.
4 things. There's 4 things.
Not hard.
Name 3 of them. I'm not even want all 4.
Hank Williams says size of disc material and material.
Okay.
Yeah.
Hank, that's 2. Can we count to 3, Hank? Need you to count to 3. Give me one more, Hank. I want to give this to you, Hank. Help me. Help me help you, Hank. Hank, are you there? Anyone else? Steal Hank's 2 answers and add your own.
That's right.
Anthony Thomas says disc diameter, material used, and spring rate.
Material used?
Material used?
I don't. Oh,
That's a little. It's damn close. You add a couple words here and there, and you're almost there.
Alexander says upgrade springs, friction material, and plate stiffness.
He's kind of talking about the same thing
Same
twice.
thing, yeah.
Yeah, same thing twice.
Man,
You guys are
I
not paying attention.
Should I
here.
start over?
You know that.
Fidel says size of disc, material used, and flywheel.
No, you're totally wrong.
Flywheel? No.
100% wrong. Don't know what to do here. You know, this is what's going on too with COVID, okay? Kids are getting instruction just like this, and this is why they're becoming more and more stupid, because they're just not learning. We got to do an in-classroom thing. That's what we're going to bring you guys here. We're going to invite you guys, everybody that's watching us, you guys are invited here next time. when we do this, so that you can
Hey,
understand in
I had
person.
fun doing that.
Yeah, that'd be fun. We'll do that. All right. You guys are getting so damn close. Can you please just guess? Please just guess. Okay, I'm going to tell you now. I said I asked for 3 things. I'm going to tell you one of them, okay? So I just need 2 more. You still have to write the one I tell you. All right? The diameter of the clutch. Or what is it? It's actually the
Radius of
gyration, but we'll take clutch size for that.
Yeah.
Yeah, the clutch size.
What you're measuring in feet is from the center to the middle of the friction material.
All right.
Jay Alexander said add thermal mass.
No. Now, if we're talking about the heat capacity of stuff, Jay, you're going down the right road there, but we're talking about torque capacity.
Right.
We're talking about torque capacity. All right. So we know it's the size of the disc is one of the 3. Now there's 2 more. There's the size of the disc and
Hank says size of disc, multiple disc friction material.
Okay,
Oh,
we'll give you.
there
Hey,
you go.
thank you, Hank.
All right, Hank.
All right.
Yeah.
You're the man,
All
Hank.
right.
You are the man, right there. All right, let's go over what the 4 were, just for everybody else here.
Want me to do that? All right, here.
All right, go for it.
Torque capacity in foot-pounds. You got the clamp load in pounds. The coefficient of friction. It could be one of these 2 numbers. The number of surfaces, not the surface area, but the number of surfaces. And the radius of gyration, which you measure that in feet. So you got foot-pounds?
Yeah. So basically, the clamp load of the pressure plate, you know, when they say it's a 2,200-pound clutch or something like that, that's the pressure from the pressure plate. The coefficient of friction, what friction material is being used. Is it organic? Is it cerametallic? Is it sintered iron? Those are all going to have different coefficients of friction. And the number of friction surfaces that you're dealing with. If it's a single disc, and there's 2 surfaces, it's going to be 4. If it's a double disc, a twin disc, you're going to have,
It'll be
4. I'm sorry. Single disc will be 2. Twin disc will be 4. Triple disc will be 6. Quad disc will be 8. And then the
like
radius,
yours, right?
Yeah, radius of gyration.
You have a quad in your...
I do. I have a quad carbon-carbon clutch in the R33 GTR, and I love it.
Very nice
It's
clutch.
just, it's extremely expensive to go that route, but it works really well. It has a lot of
Should
pluses
I make
for
one
that.
for the B-Series Honda?
They probably do not make one for the B-Series Honda. They could, maybe, but I don't know. That would be a tough one. So, guys, I want to thank you all for joining us. And hopefully you had some fun being part of the live stream today. At least I had fun during the contest there. And so I know Hank's getting something. I don't know.
Oh, yeah, what's he getting?
Hank's getting the Citation 1. Hank's the man.
All right.
Congratulations, Hank. And
Good
Hank,
job.
if you follow more of those, you're gonna learn more. But before we leave you today, we want you guys to see a video of ACT and learn a little bit more about the company. And we'll be seeing you more today on D Sport Live 2020.